Hello, this is Chuck Ridgway. I'm the Automation Technology Manager here at Horner, and welcome to another Tuesday live stream. Now, in a lot of our sessions, we'll cover topics that can be at times a little bit complex, involve a lot of details, involve multi-step processes for applications. Today is going to be a little more straightforward. Today's topic is the real-time clock in the Horner OCS. Now that's a feature as I bring in my partner in crime, Mr. Casey Gardner. How you doing today, Casey?
Hey, not too bad. How's your weekend going, Chuck?
My weekend went great. I was just starting to mention that this is a topic, the real-time clock is something that we kind of take for granted, not exactly as complex as a lot of the topics we cover here. But I found, myself at least, that when I reviewed the topic in preparation for the session, that I had forgotten a few things, and I think there's going to be some useful information that we can pass on to the group today.
Yeah, I think just reviewing a lot of different topics, especially as we try to reevaluate Seascape and come up with bigger and better things for Seascape 10, especially in the future. There's all sorts of little tidbits we've kind of found along the way that either we didn't know was there or forgot was there for sure. So it'd be interesting to see what the latest deep dive has for us for the real-time clock for sure.
Yeah, absolutely. So I'll be curious at the end of this session. During the session you'll be monitoring the chat and answering any questions you can. But at the end of the session, I'm going to be curious if there's anything specific that you remembered or that you had forgotten that I uncovered today. So let's see what happens, and we'll talk again at the end of the session.
Sounds good.
All right, let's dive right in. Today's topic is the real-time clock for the Horner OCS, as we mentioned. So let's review what it is we'll be covering. During today's live stream, we'll be talking about the OCS real-time calendar clock. So again, a feature we kind of all take for granted. It's not uncommon, of course, for PLCs and operator interfaces and all-in-one controllers like the Horner OCS product to include real-time calendar clocks built into their design. And it's a feature that we don't always think about. But today we're going to talk about how we access the real-time clock on an ongoing basis from the application, how we display time and date information on the screen, different ways that we can set the real-time clock, which over the life of a machine is a fairly important function. We can set the real-time clock from the system menu using network time protocol over Ethernet or over the internet even. We can do it from a screen or from logic, a whole variety of ways to do that, and we're going to review those with you today. And then we're also going to show some compare functions that I think a lot of people don't realize are there, or they kind of forgot they're there for plenty of applications when you need to schedule a particular device or other actuator or something to turn on at a specific time. As we look at the OCS real-time clock, it's built into nearly every OCS controller. I think there's one model of the RCC that doesn't have a real-time clock built in. That's about it. And that was developed kind of for an OEM that had a requirement of absolutely no battery. So if you can't have a battery of any kind, then you can't have a real-time clock, because real-time clocks do depend on batteries to keep the time and date current. Now, in terms of how accurate the real-time clocks are that are within our products, it ranges from a few seconds per month to maybe about a minute per month. So that's kind of the range of accuracy that you'll see there. And of course, you can access the real-time clock from your application, which can have functionality that's desired in a variety of cases. We'll talk about that in a second. And there's a whole bunch of different ways that you can update the clock, how you can set it, whether it's from the network automatically or whether it's from the screen or system menu on a manual basis. Different applications that utilize the real-time clock. One of the features that has become very common and very used over the past several years is data logging. And of course, data logging requires very heavily on the real-time clock because it logs events and data and those sorts of things, and it's always time stamped. So that's where you really need that time and date to be able to accurately reflect on when those events or logs occurred. And as I mentioned a minute ago, there's also plenty of cases and different applications, maybe lighting control, for instance, when you want to turn things on and off based on the time or date. You could certainly have a scenario in a plant where during first and second shift you want those lights on full blast, maybe a reduced lighting at other times of the day, and maybe on weekends have them at a minimum level, for instance. But there's other uses, of course, for the real-time clock, scheduling, as well as production reports and those sorts of things. So features of the real-time clock. First of all, you've got local time and date that can be displayed on the screen, and of course it can be set locally as well. You have the ability to set your time zone, and that can be important when it comes to automatic updates of the clock. You also can set a daylight savings time flag. All right, now daylight savings time is handled differently all over the world, so there's no universal way to automatically set daylight savings so that it works everywhere. So what we do instead is we provide a flag that can be manually manipulated, or at least somewhat automatically with a little bit of logic, and I'll show you that as well. But we provide that flag to allow machine builders to incorporate daylight savings if they choose. And then in addition to the local time and local date, we also support and have for some time what's called Coordinated Universal Time, or UTC. So it's the functional equivalent of Greenwich Mean Time. Okay, so those are the features of the real-time clock. Now, in terms of accessing the time and date information on an ongoing basis from the application, the way you do that is through system registers. So the OCS has a whole variety of system bits and system registers that are accessible at runtime that provide a variety of different functions, including access to time and date from the real-time clock. And we offer both system registers for local time, which are in the SR44 range, as well as system registers for the UTC time, which are up in the 200s. And then in the case of advanced ladder, whether you're talking variable-based or you're talking register-based, we go to the step of actually pre-naming the variables for time and date. So that's a convenience feature there. Now, as we take a more complete look at the variables or system registers, specific system registers that are allocated to the real-time clock, what you have there on the left is you have a list of the local time system registers. And as you can see, you've got 3 registers that deal with time, starting with seconds, followed by minutes and hour. And then you've got another 3 that deal with date. So the day of the month, effectively the month and the year. And then there's also a day of the week system register, which effectively is calculated by the OCS. If the OCS knows what date it is in time, then it knows what day of the week it is in time. So that's what you see there on the left. That's local time, if you will. And for the most part, local time is what you're going to use in your logic and on the screen, because generally that's what machine operators, for instance, care about, and shift managers and folks that are paying attention to quality metrics, they are interested in local time generally. Now, in addition to local time, which is on the left there, you've also got UTC time, which is on the right. And you've got the same basic or very similar set of system registers available for universal time. So starting with system register 212, you can see the same 6 registers, if you will, at least in terms of content. Seconds, minutes, and hours, followed by date, month, and year. Now, there's a couple extra ones there at the top, 210 and 211, and that is used for time zone as well as the daylight savings time flag. Now, you'll notice, if you look closely at those charts, that the only 2 parameters that are read-write are actually time zone and the daylight savings time flag. Everything else is read-only. Now, there are ways, of course, of setting time locally from the screen or from the system menu, etc., but it takes a special procedure to be able to write to those registers. Whereas the time zone, as well as the daylight savings time flags, those can be read or written at any time. Now, I wanted to point out that the time zone units are in minutes either ahead or behind of Greenwich Mean Time. Now, when I reviewed this, I was thinking that, okay, the time zone is going to be in hours, because we always think of time zone as being, okay, I'm so many hours ahead of this or so many hours behind of that. But the reality is a lot of time zones, or at least a few, actually are on the half hour. So they might be 10.5 hours ahead or 8.5 hours behind. So that's why just strictly a hour-based time zone unit isn't going to work. It needs to be in minutes. So that's what you have there. So you can be, the valid time zones are going to range anywhere from 12 hours behind, which is 720 minutes, or 14 hours ahead, which is plus 840. So those are your system variables, and those are accessible at any point inside your application, whether you're talking about ladder logic or whether you're talking about displaying things on the screen. Now, when we actually want to display time and date on the screen, instead of having to have individual data fields for hours, minutes, seconds, concatenated with colons or whatever with separate data fields, while you can certainly do that, it's a lot more convenient to take advantage of the actual time display object, which is available from the graphics editor of Cscape, and we'll show you that here in a second. So one thing that it's important to keep in mind is anytime that you are referencing time, you're going to want to reference, from a Cscape standpoint, you want to reference the seconds value from the real-time clock. And remember, there are 3 consecutive time values in the system registers. It starts out with seconds, followed by minutes, followed by hours. So if you're displaying time using the time display object, you want to point at or reference the seconds field. Whereas if you're displaying date, you're going to want to reference the day of the month or date field, which is the first of 3 consecutive system registers, which are date, month, and year. So that's a little tip that can kind of trip people up sometimes. They want to display hour, minutes, seconds on the screen, and they point at the hour field, which is not what you want to do. You always want to point at the first entry for time, which happens to be seconds, or the first entry for date, which happens to be the day of the month. And that this next slide here just shows that in tabular form, kind of indicating the fact that, hey, I want to display time, point at the seconds field, which is the first of the 3. If you want to display date, point at the date field, which is the first of those 3. Okay, let's go ahead and switch to Cscape now. And I'm going to show you how to utilize or how to display time and date on the screen. All right, let me go ahead and change my mouse here. So let's go ahead and go to the graphics object. Well, before we do that, let's take a look at our variables. What I have here is a program that is based around the tag-based ladder, okay, or variable-based ladder as we call it. And let's take a look at the time and date variables from the real-time clock. Now, with our variable-based ladder, which is shown here, we predefine for you the variables for date and time, okay, and they're all listed here in alphabetical order, if you will. All right, so remember, when we want to display time on the screen, we're going to reference seconds, and when we want to display date on the screen, we're going to reference date. So let's go to the screen editor now. All right, and what I have here is an EXLW, which is a widescreen 6-inch model. And just to make things nice and big so we can see them easily here on the screen, I've placed 4 of these time display property windows here. Okay, so I've got 4 objects here displaying date and time. The first 2 are displaying local time and date. The second, the universal time and date. All right, and then down here I've got some separate data fields that are not related to time. At least they're not using the specialized time data object for displaying the time zone as well as the daylight savings flag. All right, so I'm going to double click here under local time, and you can see that to display time I am pointing at the seconds variable, and I have a choice of a whole different variety of ways that I display time data, hours, minutes, seconds. I can display it in military time, you know, the 2300 for instance, or I can display it with an AM, PM type time as well. Let's go ahead and just stick with hours, minutes, seconds, and military time here. All right. And then on the date side of things, I want to point at the date register, okay, which I'm doing here. And that will allow me to show month, date, and year by pointing at the date register. And again, you've got a variety of different formats that you can choose from for displaying date. Okay, so that's pretty straightforward. And in this case, I'm showing my local time as well as universal time. Let's see what it looks like at runtime. I'm going to go ahead and show you that particular OCS by going to my overhead camera. All right, so what we have here is this display on the screen. As you probably have noticed, the time and date are just wrong. Okay, and I kind of intentionally did that so that later on I could show you how that we can actually go in and set the time and date to the proper values. But as you can see here, we are set up for no time zone difference, okay, which would only be true in the Greenwich area if our time was right at Greenwich Mean Time. And I don't have the daylight savings time flag on either. Okay, so this is going to need to be set to a more accurate value for sure a little bit later on in the program when I show you how to set time and date through a variety of different means. All right, let's head back to our slideshow. And next, let's talk about the different methods of setting time and date. So there are basically 4 different ways we can do that. We can set it from our PC in Cscape. We can set it from the system menu. We can use something called network time protocol, where we get the time from a local network or from the internet. You know, there are a variety of time servers that are available on the web, and then your IT department can set up their own time server inside your plant, for instance. And then there's also the ability to use function blocks in logic in combination with, let's say, screens that you set up for your users to access, so you can actually set the time that way. All right, let's take a look here. Now, the process that you're going to want to follow effectively when it comes to setting the time and date is this. You're going to want to start by setting your time zone. And remember, that's the number of minutes, plus or minus, from Greenwich Mean Time. Next, you're going to want to either set or clear the daylight savings flag. So as we are broadcasting this particular session today on June 1st, 2021, we are right in the middle of daylight savings, so we're going to want our daylight savings flag to be on. So after you've set those 2 things, then you want to set your local time and date. Now, the reason we don't have you set the UTC time and date is because very often it's a human that's setting the time, and they have a much easier time understanding what the time is locally than having an idea of what the time is at Greenwich right now. So that's why we, in the OCS, have set it up so customers can set the local time. And then after the local time is set, then the day of the week is calculated, because as long as the OCS knows the date, it knows if it's a Tuesday, Wednesday, whatever the case may be. And then it also will calculate what UTC is and make that available through system registers as well. Because we have some customers with some machines that like to reference everything from UTC because they have machines scattered throughout wide geographies in different time zones, and they want to have the ability to have a common time zone effectively that all the machines are in. So for some functions like data logging, they will use things like UTC. Okay? So that's the general process that is followed. So next, let's show you how to do some of those things. All right, and we're going to start that from the system menu. So let me get my unit set up here again and switch to my overhead view. All right, so let's start by setting the time and date from the system menu. Now, this happens to be an EXLW that does not have dedicated function keys or a dedicated system button, but we can access that by pressing in the upper right-hand corner where you see the system button appears, and we can press that. Now we have, as one of our choices, set time and date. I'll select that now. Okay, so as I mentioned a couple slides ago, the first thing we want to do is we want to set our time zone. Okay, now from the system menu, we make it easy on you to just go ahead and type in your time zone in terms of hours and minutes, and whether you are behind Greenwich Mean Time or ahead of Greenwich Mean Time. So in this case, I'm in the Eastern Time Zone, so I am minus 5 hours from Greenwich Mean Time. So I'm going to hit Enter for time zone, switch that to a negative value, move over one place, and go to 5 hours. 2, 3, 4, 5. Got it. Hit Enter. Okay, so I've now set my time zone at minus 5 hours. And then I'm going to set my daylight savings. And as I mentioned before, we are recording this on June 1st. So I'm going to go ahead and say, absolutely, we are right in the middle of daylight savings right now. Okay, now my time is still way off, but at least my time zone and daylight savings flags are set properly. Now I'm going to go ahead under time, and I'm going to go ahead and set to something that's pretty close to the local time. So right now it is about, it's about 14:22 locally here. So I will go ahead and set this to 14:23 and hit Enter. And my date is the 1st of June in 2021. So we will change that here. Okay, 1st of June 2021, hit Enter there. Okay, and as you can see, the OCS knows that it's Tuesday. So I've got the time pretty close. It's not exactly right, but it's relatively close. And if we go back out of here, we can see now that indeed my local time is shown as 14:24, which is pretty close. And we're on the 1st of June. And then my UTC time is shown as, when you compensate for daylight savings, it's shown as 4 hours from my current time. Okay, my time zone here is at minus 300. Remember, that is 300 minutes, which equates to 5 hours, and my daylight savings time flag is on. So let's do something interesting here. Let's go back to the system menu, and I'm going to change the time as if it was, let's say 11:30 at night. Okay, so let's change it to 23:24 instead of 14:24. And you know, when I do that and go back out here, you'll see that if it was truly 23:24 here, it would already, the date would already have changed in universal time, because when I get within 4 hours of midnight, the date is changing from a universal time standpoint. So I just thought I would point that out, that the date doesn't always match. Sometimes it's actually will actually change depending on, you know, where the UTC time is in reference to your local time. Okay, so that is using the system menu to set the time and date. All right, the next thing I want to show you is setting the time and date from Seascape. So I'm going to go ahead now and switch back to Seascape. All right, and I will go ahead and close out of the graphics editor. Now I have to make sure that I'm communicating with my controller, and I am, as you can see in the lower right hand corner here, local 253, target 253R, so I'm online and communicating. And if I go to the controller pull down menu, there is a view set clock option. Okay, so from the view set clock option, if I were to press this button right now, it would take the current time on my local PC, whatever that happens to be, and it would download that to the OCS. If I would press this button, it would take the settings from down here, which I would have manually typed in, and it would download those to the OCS and set the clock. So I'm going to go ahead and set the system time from here. All right, and I'll just go ahead and flip back to the OCS. And it may have been hard to see, but we did adjust slightly the current time from the, what I had set it before manually, and I was 15 or 20 seconds off probably at least, to the point now where we're probably within a second or two at worst. Okay? All right, so that's a second method you can use to set the time and date, and that is using your PC from Seascape. Okay, now the next one I want to show you is probably the most useful one of all, and that is using NTP, Network Time Protocol, to set the clock. So let's go back to Seascape, and let's show you how to set that up. Okay, so I'm going to close this dialog here, and let's go into the hardware configuration area of Seascape. All right. And NTP is an Ethernet-based protocol, so we'll go under LAN 1 configuration here. And before you can use network time protocol, you have to make sure that your network is set up properly. So at the very least, you have to have your IP address and your netmask set up right. Now, if you're going to be accessing a time server that is outside of your building, in other words, over the internet, you're going to also need to make sure that the gateway is properly configured, and you probably should make sure also that you have a DNS server also configured. In my case, I've configured one of the Google DNS servers here. So with these two things properly configured, we now have the ability to go outside of our building to get time for synchronization purposes, as well as type in the name of the website as opposed to just typing in the actual IP address of the website. Okay? All right, so the prerequisite for getting NTP to work is to have your networking set up properly. Now that we've done that, we can take a look at the resident protocols and see NTP protocol is available on the list here as a resident protocol. Now, one thing I'm going to mention, this is really kind of an inaccurate note. It basically says getting the clock from a web-based server. While that is true, you certainly can do that. Your IT department also can set up internally inside your firewall. They can also set up an internal NTP server. And if your IT department does that, then you can use NTP to synchronize the time on your units from an internal server where you're not accessing the internet. So that's also an option, just to make sure that you're aware of that as well. But once we have NTP configured, we can hit the Configure Selected Protocol button here. And this is where we can add a list of one or more network time servers that we want to reference. Now in my case, I usually like just to use one that's available from the US government. I believe it is called time.nist.gov. time.nist.gov. All right. I'll say OK there after I make sure I did indeed type it in properly. There we go. And with that configured, I can go ahead and download that to the OCS, and then the OCS will use that time server to synchronize its clock. Now let's go back to the OCS real quick from my overhead cam. All right, and let's just go in and screw up the time and date a little bit. All right, so we can tell when we've changed it using NTP. So I'm going to go back to the system menu. I'm going to go back to set time and date, and I'm just going to quickly change the time to something that's way off, and the date, I'll do the same thing with that as well. Okay, so I've changed the time and date so it's wildly inaccurate. All right, now let's go back to Seascape. Let's go ahead and do a download. So I will download the program here. All right. So Seascape will go through and figure out what has changed. It'll warn me that, hey, you're configuring or you're programming over Ethernet, so be careful that you didn't screw up your IP address. Otherwise, we could get partway through our download and lose communications, which is never good. But I had everything set up properly, so that's all working as it should. Let's switch back quickly to our overhead view and keep an eye on things. And already, it's already changed. So that happened super fast. All right, because it is indeed in the Eastern time zone, that is accurate time. All right, now notice when you do the NTP, it only is going to affect the time and the date. It's not going to impact time zone or daylight savings time flag. Those are things that you have to handle independently of network time protocol. So be aware of that. You'll either have to set that, from a data field on the screen, or you'll have to set it from the system menu or something in that area. So even when you use NTP, you still have to set your time zone and your DST flag properly. Okay, so that's network time protocol. Pretty straightforward, and it provides a great way for the OCS to stay accurate from a clock standpoint. Now, a question you might have is, how often is the OCS going to be referencing or accessing the NTP server, in this case at time.nist.gov? Well, it's going to do it typically on power up and then every few hours after that. We're careful not to over ping or over access the time server, otherwise we could get blacklisted, or your machine could get blacklisted, and you don't want to do that. So just be aware of that. It's not going to continuously access it, it's going to access it on an occasional basis. Okay, let's go back to our slides and let's finish up with our material here. Okay, the last method for setting time and date is through a function block. So that's the set time function block. So what it allows you to do is to configure as the input to the function block a list of 6 consecutive register values that contain the new time and date settings that represents the new time and date that you're looking to set the real-time clock to. Now, if you're using register-based ladder, you're going to use just 6 consecutive %R registers probably, making sure that the data is in the appropriate order. And that's going to be, of course, seconds, followed by minutes, then the hour, followed by date, month, and year. All right, so that's the order you want them in. If you're using variable-based ladder or IEC 61131, another option, or maybe a better option, is to set up a variable as an array or a dimension variable with a dimension of 6, so that those 6 values for seconds, minutes, hours, date, month, year can be in consecutive indexes or consecutive entries in an array. So that's what you can do for that approach. So that's the last method, if you will, of being able to set the time and date. And you can use this function block in conjunction with a screen that you develop to provide an easy way for your operator or your maintenance person or your shift supervisor to be able to access, let's say, a password protected screen that you set up, and let them change the time and the date manually if that's what you want them to do. Because let's keep in mind, a lot of machines aren't connected to networks or the internet for sure. So you'll want to have alternative means, maybe a means without them accessing the system menu. Okay, so now let's show how that works. All right, I'll go ahead and flip back to Cscape now. All right, and what you see on the screen here, there we go. Again, I'm using variable-based ladder. So I have a single normally open contact that when it is enabled, it's effectively enabling this set clock function block. I'll double click on it here, and the input to my set time or my set clock function block is a single array that happens to have a dimension of 6, which contains what I'm calling the new time. And once again, that is the seconds, minutes, hour, date, month, and year that I'm going to be setting the clock to. All right. Now we have to have some way of entering that information in. So let's create a screen. All right. That allows the operator or shift supervisor or whoever's setting the time and date on the machine, that gives them the ability to enter in a new time and a new date. And these utilize those time data display objects that we talked about at the beginning of the session. So I'll double click here, and for the new time, all right, remember we're talking about the time now, we're going to reference seconds, and seconds is the very first entry in this array of 6 objects. All right, so it's important that we reference the appropriate member of that array. And then for date, we want to reference the 4th member of that array, because we have 3 that deal with time, and then the 4th one is the date that we need to reference to display and enter in dates. So you can see number 3 of our index, and remember indexes start from 0, so 0, 1, and 2 deal with time, 3, 4, and 5 deal with date. Okay, so we've set this up for our user. They can enter this information in here, and then when they're done with that, they'll press the set button, and that set button is tied to that enabling contact in my logic. Okay, so it's really just a matter of them entering this information in here with the new time and date and hitting the set button. So why don't we go ahead and show that as well. So let me flip back over here to my overhead view. Well, before I do that, let's go back into logic and let's go into debug mode. Okay. Then we'll flip to our OCS. All right. And I can go ahead and enter in, oops, at first I got to switch to the proper screen. There we go. Let's say I'm going to change the time to 17:20. You have to use the arrow keys here. You're not allowed just to manually enter it in. All right, so let's say that's my new time. I then hit the set button, and as you can see, it changed. Now, if I didn't have this function block working in the background, then it wouldn't work. So I'm going to go ahead and execute it again, and you can see in debug, you can see that's what's happening in the logic. Okay, so that's another method for setting the clock in your OCS. All right, now back to our content. We'll button this up. Okay, now a lot of people want to be able to, with their machines, they want to be able to automatically deal with the daylight savings flag on their machine. They don't want their customers going in and manually setting daylight savings because, you know, they'll end up with data logs that are inaccurate because somebody will forget to set the flag and all those sorts of things. So it is quite feasible to deal with daylight savings in logic, to set that flag and clear that flag in logic. And that's what we're actually going to show you now. All right, so back to Seascape. And this is a pretty practical thing to want to do, is to deal with that flag in logic so that your customer doesn't have to deal with it. All right, so how are we going to do that? Well, first of all, in the area where I live, which happens to be in the United States, in the Eastern Time Zone, we start daylight savings the second Sunday in March, and we end daylight savings the first Sunday in November. So I'm going to use something called, I'll have to get out of debug mode first, but I'm going to use something called time and date operations to detect the second Sunday in March and the first Sunday in November so that I can turn on and turn off the daylight savings flag at those appropriate times. Okay, so I'm going to go ahead, and I always want to check the time and date, so I'm going to go ahead and add the always on contact here. All right. All right, and I'll make sure that I have started a new rung since I did not place it in column A. It doesn't automatically create the new rung for me. Now I'm going to go ahead and build a simple piece of logic that detects the second Sunday in March using these time and date operations. So the first thing I want to check is it March, right? That's the first thing I want to check. So I take this month of the year function block, and I'm looking for a fixed time, and I'm going to set that to March. Okay, so if it's March, it's going to pass power flow. Next, I want to check and see, is it Sunday? All right, so I'm going to select Sunday. So if it's March and it's a Sunday, then it's going to pass power flow. Now let's talk about the day of the month, because I only care about the second Sunday in March. Well, that means that it can be anywhere from the 8th through the 15th. Okay? Or I'm sorry, 8th through the 14th are the potential dates for the second Sunday in March, because if I checked one of the first 7 days, okay, that could be wrong. So it's got to be the second Sunday. And the earliest it could fall would be the 1st, and the last it could fall would be the 7th in terms of the first Sunday. Okay? All right, so if it's March, Sunday, second Sunday, and we happen to do it at 2 o'clock in the morning is when we do the switching. Let me go ahead, and it's already set to 14. Let me change that to, or no, we want 02. We don't want 14. Let me change the time here to 2 o'clock. Okay, and we'll go ahead and just end that a minute later. It's not going to end daylight savings. Remember, we're going to use a set coil to set our flag. We're not going to use a on and off coil in this case. Oops, got to be able to manipulate my mouse properly. All right, and this time isn't as critical as long as it's after that. but I'll go ahead and make it 1 minute later. Okay, so at 2 o'clock, we'll pass power flow to a coil. We'll stop passing power flow to the coil at 2:01, but as long as we make this a set coil, now we want this to be our daylight savings time flag, and I've already set up a variable that's mapped to the appropriate system register for the daylight savings flag. Now, it's mapped as an integer, and I'm only interested in the first bit, so I have to put a .1 here. Otherwise, it would be looking at it as an integer. I just want to look at that first bit, which is my actual flag. Okay? All right, and I want that to be a set coil. All right, so this is going to turn on daylight savings on the second Sunday of March at 2 a.m. And we can very quickly and easily copy this rung, hit paste, and I'm going to quickly run through, change this from March to November. It's still a Sunday, but it's the first Sunday, so it's going to be 1 through 8 instead of 8 through 14. Hopefully I need to be better with my mice here. I'm a little slow. Okay. All right. And it's still at 2 a.m. And we're going to not set the flag, but we're going to reset the flag. Okay, so that should take care, unless I've made a mistake somewhere, that should take care of daylight savings on this machine, provided that it's in a part of the world where the 2nd March is when we turn on the flag, and the first Sunday in November is when we turn it off. Now, I could very easily set up variables for all these things and not have them fixed. So there could be, I could set up a screen where somebody could set which Sunday or Monday or what day of the week. Is it the 1st, 2nd, 3rd, or 4th, or 5th? You know what I'm talking about. This could all be set up as variables on a screen, and the user could then effectively change these if necessary in case the laws changed or the location of the machine changed, or whatever the case may be. So I've set it up as kind of a fixed thing in logic, but it doesn't have to be that way. Okay, so I think that pretty much wraps up the material that I wanted to show you today. So let me go ahead and bring in Casey again. Okay, so you never thought that we could cover almost 45 minutes on the real-time clock, did you?
You found a way, for sure.
Yeah, although if I was a little quicker with my mouse clicks, it probably could have been like 35 minutes. So I think it felt like it took forever to click those mice. Okay, so was there any little tidbit of information that I presented that either you had forgotten or you didn't know to begin with?
Absolutely. So one thing in particular was the NTP protocol. I forgot we added that in a little while ago. It wasn't too long. It was a couple of years or so.
Right.
Just kind of sneaks into the resident protocols that we have, which is pretty nice. And there was one more thing, but I forget off the top of my head. So yeah, it's always little useful tidbits. It's really nice to have, for sure.
Absolutely. Okay, very good. And I will also add that NTP isn't supported by all of our products. It's primarily supported, I believe, by the XL series from the XL4 on up. It's also supported in the X5, and then it's also supported in the RCCs, except for the RCC 6512. It doesn't support it, but the rest of them I believe do. So again, at some point I'm sure we'll have NTP support for all of the controllers, but at this stage it is a subset. All right, very good. Thanks for your help, Casey. All right, so
no problem.
Let me mention the fact that every Tuesday at 2 o'clock Eastern Time, we've got our weekly live streams. If you can't watch them live, they're always available on replay, or available whether it's that same week or available 6 months from now when you finally get around to programming that daylight savings into that machine. You'll have a place to come and reference the information. Now next week should be a fun program. We're going to talk about integrating stepper motors with the Horner OCS. So this is definitely a function that has been requested, or a topic that has been requested multiple times. We're going to show multiple different ways of integrating stepper motors with our products, keeping in mind that stepper motors are a special kind of motor. They're great for positioning. They've got some terrific characteristics. They're pretty low cost. There are definitely scenarios where a stepper will work better than a servo. Of course, a lot of scenarios where a servo works a lot better than a stepper for that matter. But don't forget to join us next week for integrating stepper motors with the Horner OCS. So once again, thank you for joining us. We look forward to seeing you again next week. And everybody continue to stay safe out there and have an awesome week.